So we're going to give a quick tour of that Roland MDX-540. This is the machine right now. This is also the table that I offer. It's casters and adjustable height. Also has a laptop arm as well. Changing tools. You put it on this device right here. Loosen and tighten it up and put the tool in. When you open up the machine, 4 position tool changers right here. This is the tool we're going to be using for it. The red piece that you see is actually just a sacrificial base because you have to cut through your sample. I put double-sided tape down on your sample. We're literally just simply putting it down against this one side and pushing it down so that double-sided tape adheres. An actual vacuum table would work better because you have some of the basically glue from the double-sided tape gets on the side wall of your samples, and it would work better with the vacuum table. There's 2 softwares involved. One is the V panel, which controls the actual X, Y, and Z homes of the machine and allows you to select tools. Right now we're going to go to attach tool, and we're going to select tool number 1 and put it in the spindle. We then use the handy panel, which is attached to the machine. It allows you to move in the X, Y, and Z direction as long as the 4th axis and turn the spindle on. It basically allows you to use it as a manual machine. We're going to set the Z origin, i.e. it's going to measure this tool based off of this. It knows the thickness of this, so the surface of our cut part will be 0. The tool automatically lowers down onto the sensor, and when it makes contact with it, it will retract back up. Now your Z origin 0 is set. Next, we're going to set the XY origin, basically just by jogging the machine toward the lower left-hand corner of it. And when we have that, we'll go to the V panel software and say make the base point, set the XY home here. Choose apply and say close, and then you'll see the X and the Y are 0. The Z is slightly high because we have it slightly high. Next, we are going to go into the Visual Mill Cam software. This is the add-on cam software that I'm recommending because it allows you to draw geometry as well as more functionality as far as machining. So basically what you're doing is just choosing curve modeling. I'm just going to choose rectangle. If you can see the green and the red arrows, that's the XY 0. So basically this 0 on the machine is the same as the 0 in the software. So we're just drawing a rectangle 2.5 inches by 1/2 inch, and that's the size of your smaller samples. There's your sample rectangle. Once you have your geometry drawn, or you could have it drawn in a different CAD software, and you can actually use any CAM software that you want. This one is just affordable and has all the functionality that you need. So really what you're doing is 2-axis machine, and all you're doing is profiling. In the first part it says choose your geometry. All you're choosing is this rectangle. The next is choose your tool. There's a flat 125. Check your feeds and speeds. We are okay with the feeds and speeds. It has a lot more control than what comes with the machine, the SRP player that comes with the machine. Plunge, engage, attract, a whole bunch of different controls of feeds and speeds, but you're going to have a general standard that you're going to run with. In the cut parameters, we have a tolerance. You want to do a mixed type machining and use outside inside. We're cutting the outside of the rectangle. In the total cut width, we are going to put 0.006 thousandths cut levels. Total cut depth is going to be 0.14. The rough depth, or how fast we're going to cut on each level, is 0.008, 8 thousandths. The rough depth, so then the finished depth make 004. And the entry exit, we're going to do lines and arcs, but we're going to make them small. So basically, once you set up these parameters, you can kind of control everything and change it very easily, but we're going to be taking 8 thousandths off at a time. We're going to do 2 pass, an outer one leaving 6 thousandths on, and then an inner one cutting it to the proper size. After you set your parameters, you choose generate, and you'll see the tool path in the light blue color. See how it feeds in, feeds out right there, and that's basically it. So now we're ready to basically literally send this routine to the machine. The handy panel will allow us to control feeds and speeds while in operation, so you can increase or decrease spindle RPM and feed rate while in operation, or pause the job as well. Once you have the CAM software programmed, you just literally right click on the routine, choose post, say post, and away it goes. Now the machine will activate. I'm going to actually speed it up a little bit because I'm not having problems with anything. A little bit faster. Pardon the noise. We can be more aggressive on the cut and increase the feed rate as well. I'm just kind of throwing this all together real quickly, but I would guess I could probably get this done about twice as fast as what it's taking to cut. You can't go too far on this type of material because it's brittle material, and when I went too aggressively running the test, it basically shattered the sidewalls a little bit or broke out chunks of the sidewall a little bit, and I don't think that's what you're looking for. In order to hold the smooth sidewalls when you're cutting it out, I've just taken more steps down, and also doing a rough and a finished cut on each pass. So every time it goes down once, the first time it leaves 6 thousandths on, the second time it'll go down and cut it to size. I have found by being too aggressive with this material, say if I wanted to take out 1 millimeter at a time, I can cut it out fairly quickly, but again, because of the brittleness of this material, you didn't get a desired finish for it. This also might be able to be solved by using a coated type of an end mill that is made more for cutting this type of material, and that might be able to allow you to go more aggressive as well. We're breaking through, we're going through into the sacrificial base at this point now, so we're just about done with the sample. As you can tell by the red showing through, it was actually cut all the way through. The other thing, you'll see a buildup on the bit itself. That is the double-sided tape coming off on it, and that's kind of why I would rather you guys use a vacuum table than the double-sided tape. Anyhow, the part is done. Now I can just simply break the part out. There's your sample. Just smooth it off. Again, sometimes I'm seeing a little bit of tape residue build up on here, but overall, that's just the double-sided tape on it. That's the sidewall that you get. About that. So we're going to do an array of the part. So in transform, you have the option of array. In the X spacing, we're going to make it 3 inches and make 1 copy. In the Y spacing, we're going to give it a gap of 0.75. We're going to make 4 copies. Z spacing would remain at 0. When we do that, now all of a sudden you have an array of parts. So you can just go into that routine that cut the 1 part, and then go into control geometry and say select edge regions. So we could select this guy, and this guy, and this guy. So now all of a sudden we have quickly a generation of 3 routines. So now you can see the routine would cut out 4 at the same time. All right.